Page 7 of Quadratics for Math Studies. Let's see, find the equations of these quadratic functions. One helpful thing that they show us here is they show us what a parent function looks like for a quadratic. If you remember, the vertex is at 0, 0. It's got at the first point 1 unit to the right is at 1, 1. The first point to the left is at -1, 1, and the next point would be 2, 4, and -2, 4. So you can see that the height of the first point over is 1, and the height of the second point over is 4. Okay? It's 4, 4, 1, and 1. Okay, so if you see a parabola and it has that basic shape where it's 0 height in the middle, 1 height to the left and to the right, and 4 high, 2 to the left and 2 to the right, then you know it's a parent function, so the a value is just 1. Okay? All right, so find the equations of these quadratic functions. One of them is red and one of them is blue. It's very hard to see that, isn't it? So first we'll look at the blue one. The blue one here, it has a vertex at -2, -5. So the vertex is at -2, -5, which means it's right there. So since we know the vertex, and we also seem to know that this particular parabola is a regular sized parabola with the parent function of equal to this parabola there, because we can see that like the height in the middle is 0, the height to the left is 1, the height to the right is 4, the height to the right is 1, and the height to the right is 4. So it's the same as the parent function, which means the a value is 1. Let's write down the standard vertex form here, which is like that. The a value we know is 1. It's positive 1 because it opens up, right? Now what about the h and k values? So it's -2 and -5. So x minus -2 squared minus 5. Do you see how we put -5 in for k? Now, since we put negative here between x and 2, we can make that a x plus 2 squared, right? Minus 5. And the a value, since it's 1, we could just write nothing there. Okay? So there is our function for the blue parabola. Let's look at the red parabola. The red parabola has a vertex at -1, -3. -1, -3. We're going to write vertex form again, okay? So in this case, the a value, let's check out the a value. Is the a value just 1? So if we go left 1, it's height 1. If we go left 2, it's height 4. Same thing with the right side. Height 1, height 4. So that means that it is a standard sized parabola, the parent function. So we could just put a value of 1 here. And then the h value in this case is -1. So we're going to put x minus -1 squared. And then the k value is -3, so we put -3 here. We just replaced plus k with -3. Now, since we have x minus -1, we're going to simplify that into x plus 1 squared minus 3. Did you notice that the 1 also, we could just make it disappear because multiplying 1 does nothing, so we don't need the a value of 1 there. So there is our red parabola equation, function. Okay, let's look at number 2. Number 2 also has a red parabola and a blue parabola. Let's do the red parabola first. The red parabola has a vertex. It seems to be, let's see, where is the vertex? I can't really see the x-axis and the y-axis here, but this apparently is the y-axis. This is the x-axis. Okay, so the red parabola seems to have its vertex at 1, 2. 1, 2. Okay, and let's check out the size of this parabola. If we go 1 to the left, it is 1 high. If we go 2 to the left, it is 4 high. If we go 1 to the right, it's 1 high. If we go 2 to the right, it is 4 high. So it is a standard size parabola with an a value of 1. So I'm going to write here y equals, we're going to write first the standard vertex form, which looks like that, right? The a value, as I said, is 1. The h value depends on the vertex. The vertex here is 1, 2. So it's x minus 1 squared plus 2. Okay, so this is a, let's see, we could simplify it a little bit by getting rid of the 1 here, because the 1 multiplying by 1 does nothing, right? So we could just write y equals x minus 1 squared plus 2. Let's do the blue parabola now. So the blue parabola has a vertex here, which seems to be at 2, 1. So the vertex for the blue parabola is 2, 1. What about the size of the blue parabola? So if we go left 1, it goes up 1. If we go left 2, it goes up 4. If we go right 1, it goes up 1. If we go right 2, it goes up 4. So we're going to write our standard vertex form here again. And in this case, the h value is 2 and the k value is 1, and the a value is 1, of course, because it's a standard size parabola. So we got that. And we could get rid of the 1 a value because multiplying by 1 does nothing. So we got that. Let's move on to number 3. So number 3 has some parabolas that are opening down. It's a little bit trickier. So let's look at the red one first. The red one is here. Okay. The red one has a vertex at x equals 1, y equals 4. 1, 4. Let's see, and it opens upside down. Let's see the size of this parabola. When we go left 1, it goes down 1. If we go left 2, it goes down 4. If we go right 1, it goes down 1. If we go right 2, it goes down 4. So this is just a regular sized parabola, except for it's opening down. Okay, so since it's opening down, the a value is going to be -1, okay? Okay, there's 2 ways to write this one. One is to use vertex form like we've been doing, okay? So y equals -1 x minus 1 squared plus 4. Okay, so that's one way to do it. Another way to do it is to use factored form. Remember factored form from the roller coaster investigation? So we got an x-intercept at -1. We got an x-intercept at +3. So we got p equals -1. We got q equals +3. So another way to write the red parabola equation would be a times x minus p times x minus q. So it would be -1 times x minus -1 times x minus 3. So you can see that if I have minus -1 here, that cancels out and makes a plus. So I could write negative x plus 1 times x minus 3. And if I expanded this and expanded this, I would find out that they're the exact same thing. Okay, so you can write them either of these 2 ways is fine. Okay, let's do the blue one now. So the blue one has a vertex at 2, 9. So I know that I could probably write it in vertex form for sure. And so if I go left, I go down 1. If I go right by 2, or left 2, then I go down 4. If I go right 1, it goes down 1. And if I go right 2, I go down 4. So I can write the equation for my blue parabola because my a value I already know is -1. How do I know it's -1? Because it's a regular sized parabola and it's opening down. So I could write y equals -x minus 2 squared plus 9. Now, how could I write it in factored form? Do you see the blue parabola has x-intercepts at -1 and at +5? Okay, so I could write it also as y equals -1 times x minus -1 times x minus 5. And you can see that x minus -1 could be simplified into x plus 1, x minus 5, right? So that's another way to write it. I could either write it in vertex form or I could write it in factored form. What about number 4? Number 4. So let's do the blue parabola first. It's got a vertex here at -2, 5. So the vertex is at -2, 5. What about its proportions? When I go over left, it goes down 2. Ooh, interesting. When I go over 2 to the left, it goes down, wow, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so instead of going down 1 here, it goes down 2. Instead of going down 4 here, it goes down 8. So you see how it's going down twice as much as it should? That means that the a value is 2 or -2. I know it's -2 because it opens down. Okay, so now I could put y equals -2 x minus -2 squared plus 5. Why did I put minus -2? Because it's -2, so it's minus -2. Why did I put plus 5? Because it's just plus. It's a plus k, and k is 5. So now I can simplify a little bit. I can write x plus 2 squared plus 5, right? So there is my vertex form equation for the blue parabola. Now, could I have written this in factored form? Well, I could have, but it's not really easy to do because look, the places where the blue parabola crosses the x-axis are not whole numbers, so it's hard to see what it is, right? Let's try to do the red parabola now. So the red parabola has a vertex very close to the blue parabolas. It seems to be -1, 5. So the red vertex is -1, 5. What about the a value? The a value of the red parabola, we go over 1 and it goes down 3. We go over 2 and it goes down, wow, really far. I don't know if I can even count that much, okay? I don't know if it's 11 or 12. It's hard to see, right? Well, we could just judge by this here. So when we go over 1, when we go to the left by 1, we go down 3 instead of going down 1. So it's going down 3 times as fast, right? So from the measurement here, we know that a value is going to be 3 or -3 because it's going 3 instead of 1. So the a value is going to be -3 because it's opening down, right? If it was opening up, then it would be +3. So we know a equals -3. So let's go ahead and write our equation now. It's going to be -3 times x minus -1, which is the h value, squared, plus 5. Now we can simplify the minus negative here and make it a plus. So it's -3 x plus 1 squared plus 5. Okay. All right, so we have the vertex form equation for the red one also. All right, now let's go down and do the last one, number 5. So on this one, we have one parabola opening up and one parabola opening down. Let's see, let's do the blue one first. So the blue one has a vertex right here, and it's opening down. Let's check the dimensions of it. When we go over 1 to the left, it's going down 1. We go over 2 to the left, it goes down 4. So it's a regular sized parabola, except for the a value for the blue one should be -1 because it opens down, right? So, and we know that the vertex seems to be 0, 3. So our resulting function is y equals -1 times x minus 0 squared plus 3. So it's -1 x squared plus 3. -x squared plus 3. So that's the blue parabola. Now let's take a look at the red parabola. The red parabola, this is probably the most challenging one we've done so far. Because look, we can't use the vertex because we can't really say where the vertex is. It looks like the vertex might be at -1/2, -1/2, but we don't know for sure, right? Ooh, but what we can see is that the x-intercepts seem to be at -1 and 1. So P is equal to -1, Q is equal to 0. So we might be able to write the equation there. Let's see if we can figure out the proportions of the parabola. No, that's going to be really hard to do because it is, let's see, if we go one to the left and then up, wow, it looks like it's going up 1.5. If we go 2 to the left and up, it's kind of hard because there's not whole numbers. It's a whole bunch. Okay, so let's do the best we can. What we're going to do is we're going to write the equation. This is a really challenging one. So we're going to write A because we don't really know what A is yet. We do know A seems to be positive because it's opening up, right? But that's pretty much all we know. So x minus -1. And then the Q value is 0, so x minus 0. So minus -1 cancels out, so we end up with A times x plus 1 times x, right? So basically we got A times x plus 1 times x. And now I'm going to show you a way you can figure out the A value by using one of the points that happens to fall on the grid. And I recommend either this point, which falls exactly on the grid, or this point, which falls exactly on the grid. Now you're going to say, what about this one and this one? We already know that 2 of the points that fall exactly on the grid are 0, 0, and -1, 0. The problem with those is, since they're on the x-axis, they don't help us find A, because A could be pretty much any value, and the x-intercepts would still be there. Okay. So let's use this one, for example. This coordinate here looks like it's 1, 4. Is that right? Yeah, it's 1, 4. What we can do is we can substitute x equals 1 and y equals 4 in for the x values and the y values here. So we'll rewrite it here. Y equals A times x plus 1 times x. We're going to substitute in x equals 1 and y equals 4. We're going to get 4 equals A times 1 plus 1, which is 2, times 1, which is 1. So we have 4 equals 2A. So A is going to be equal to 1/2, right? If I divide both sides by 2, I'm going to do this in a separate place because we're going to rewrite here 4 equals 2A. So what I did was I write this and I write this next to each other. Then I'm going to do the algebra. I'm going to divide both sides by 2. I'm going to end up with A equals 2, right? So if A equals 2, I can rewrite my fractored form as 2 times x plus 1 times x. Okay? So when you're going to write the equations or write the functions for any of these parabolas, first thing you're going to do is, do I want to use vector form or do I want to use factored form? And once you do, the next question is, what's my A value? And usually the A value you can kind of figure out by seeing how stretched it is. But if it's hard to do that because maybe it doesn't fall exactly on a whole number grid, one of the ways you can do it is you can find one particular point and then substitute it in and then do a little bit of algebra to figure out what the A value should be to make that true. Okay? Another way you might do it is you could go to the calculator and we could like go to y equals, and I could put in, remember, we kind of knew what the equation looked at. It was A, x plus 1 times x, right? So one thing we could do is we could just try out a value, 1, x plus 1 times x. This is how you can totally avoid algebra. The calculator is very powerful. You can avoid algebra. And then I graph it, and then I'm going to check to see if this is the same as the red parabola. The best way to do that is second table. So if I go to second table, I'm going to check, does it go through 1, 4? And it doesn't. It goes through 1, 2, right? So in this case, I'm like, okay, I want it to go through 1, 4, not 1, 2. So what I'm going to do is I'm going to adjust the value of A. Instead of 1, I'm going to make it 2 to see if that makes it better. And now, hey, now it goes through 1, 4. Okay, and what do you know? I guessed it right. Okay, so you can kind of guess it using the calculator, and eventually you're going to find it because the A values in a math studies test are going to be pretty well behaved numbers like 2, 3, 4, or maybe they're going to be like 1/2, 1/3, 1/4. Okay, so they're not going to be weird numbers usually. All right, that's it for this page.